Hello and welcome back to Humans versus AI. This is video 14. In the last video, we began training our machine learning agent to play the game, but we had no sight into how well that was going, and indeed we have no idea whether or not the model that has been trained would be of any use whatsoever. So to give us some insight into the performance of the training process, we're going to introduce Tensorboard in this video. As everybody knows, I have a Patreon account. If you are a patron of mine, just want to say a big thank you. And of course, you can access the code seen in these videos on a by video basis. So there's a folder for each video, so you can code as you go. And also for a while, early access to the videos. Right, let's get on to this video then. First things first though, before we get on to Tensorboard, this is the first video where we're updating Arcade to a newer version. So in previous videos, I've made mention a few times that we shouldn't really use wildcards for our dependencies, but in this project I was doing for convenience, but to watch out. Well, doing so has come back to haunt me, because whilst recording this video series, Arcade updated from 2.6 to 3, and there were breaking changes. So firstly, for those who are patrons of mine, all of the video files you'll find have pinned dependencies in the pip file, which means that the dependencies are defined for Arcade 2.6 right up to this video. And for this video, they're pinned to 3.0. So if we have a look at what that looks like, I'll just open pip file here within the IDE this time. What you can see here is all of these dependencies now have a version associated instead of being an asterisk. The one that really matters is Arcade here. Now, by upgrading Arcade to 3.0.0, two things have to be changed in the code. So before we get started, I'm going to run through what they are so that those who are following along who don't have access to the code and want to make this work, you're going to need to know what changes have been made. There aren't a lot, there are 2 lines of code, that's all. So before we get on to Tensorboard, let's look at those 2 things. Unsurprisingly, the changes, because they're Arcade, are happening within the render loop, which of course we now know is the onDraw loop. So if we go down within the game class to onDraw, we'll see 2 changes. The first one is rendering the texture, the background grid. As you recall, the background grid is a rendered texture for performance benefits, and we used to have a little bit more detail going on within the parentheses here. But now we've replaced the details for what the rendered texture's dimensions are by an object called Arcade Rect, which is stored within the variable rect. So that's a difference. So what is rect then? Well, the only real difference that's happened is the method name, draw texture rect, has changed. It's now draw texture rect. It was draw texture rectangle before. So note that. The second thing that's changed is rect is this object which basically is more well defined. We have to define the bounding box very explicitly, whereas before it was a lot simpler and some assumptions were being made. So here we have to define the left, right, bottom and top positions of our texture, which need to be the corners of the window, the width and height, which of course are the size of the window, and X and Y, which are the center position for the window. In our case, the center position, really it's the center position of the texture within the window. Which for us is right in the middle of the window because the texture stretches across the entire window. So all of this will make sense if you were to just sit and stare at it for a few minutes. The left, right, bottom, top, width, height, X and Y for the position of the texture which is stretched across the entire game window. Okay, and that's put in here. That's the first thing that's changed. Similarly, the draw filled rectangle method has changed. It's now draw rect underscore filled. This is for the energy, drawing the energy squares in the grid. So again, we've replaced the detail that was in the parentheses of the method with simply a rect object, which is defined above. And it's the same as above, really. We're defining the position and size and center point, so yeah, the position, of each energy square. And the dimensions obviously are dependent on the grid cell in pixels, which is X and Y, and the energy size, which we define above as being half the size of a tile. So if you went all the way back to I don't know what video it was, probably something like 4 as a guess. You'll find we are in the process in that video of creating the energy points. Well, this is exactly the same, it's just we're changing the way we're defining the dimensions and the position of that rectangle. Right, so with that done, and with the dependency pinned to arcade 3, just for completeness, I'll press play and show you that it works. Actually, it might try and train, because I think the last time I had this I was training. Yeah, so I'm going to stop that, terminate the training, go into constants, and change the training flag to false. There we go. Go back to main, run the file, and I just want to show that it's working. There should be one player. Ooh, what's happened there? Bit of live coding coming up. Hold on. 133. Ah, yes. Let me just go back to constants. The human player needs to be true. The reason why I'm getting an error is because at the moment we haven't implemented the machine learning model that's going to give us the action. This doesn't exist basically yet, so we won't get into that yet. I'll just comment that out, and I'll set action equal to 3 just for consistency so it'll work. That's all, don't worry about that. This is because we haven't yet used our machine learning model to play the game, which is going to go here. So for now, that's the reason it broke. So if I press play again, it should work fine. There we go. So now we can move the player around with the W, A, S and D key as normal. Arcade is working as it should, and we can collect energy, which updates the scoreboard in the top left-hand corner. There we go. I'm just going to complete it for fun, and it should say game over. It's always good just to check that things are working as they should. There we go. Yes, so in the next video, actually, it's going to be here where we're going to be using the machine learning model to give us an action, the trained model. But we don't currently have a trained model, so I've reverted back to action equals 3. So apologies, that's an oversight. Right, okay. So now we know that arcade is up to date, we need to introduce Tensorboard. So firstly, I'm going to go back to train mode equals true, because in a few minutes we're going to need to train the model to show that Tensorboard is working. Second thing to do is we need to tell the PPO library to write its logs to a Tensorboard log location here. So if we go to PPO file, go down to train model that we created in the previous video, we've added an argument here. Tensorboard logs equals the log location, which you can see up here. I'll delete this because this was created since I just ran training at the start of this video by accident, but that's where it's going to go. Relative to the project, it'll sit inside the logs folder, which I can delete because the logs folder will be created. So it's going to create logs for Tensorboard in a particular format, which will let Tensorboard read them. So it's doing all the work for us, which is another reason why it's very handy to use a pre-built PPO library, which we're using via stable baselines 3. So that's the next thing we've changed. Finally, we need to install Tensorboard. Now, if we go back to the pip file, you'll see that actually Tensorboard is already installed because I've done it before the video. But if you go to your console, and I use pipenv for this project, so I do pipenv install Tensorboard. It's that simple. We don't have to import it because we're not going to use Tensorboard within the code. We need to run Tensorboard. Tensorboard will run a server. So if I run Tensorboard, what you have to do is when it's installed into your virtual environment, make sure you are within your virtual environment, however you're managing your virtual environment, which I am because I'm within video here. You type in Tensorboard --log dir equals, and you basically point to the logs file that our stable baselines 3 module is creating for us. So I press enter, it'll start a server. And it's starting the server here at localhost 6006. This is where our graphs are going to be produced. So if I now open Edge, which I use on Windows, this is what Tensorboard will look like for you. I'll just refresh it. Now, this column here on the left will include your runs. We don't have any yet because I haven't run any yet. And here is where the graphs are going to go, which are going to show us the performance of the training. So in order to show this then, we need to actually begin the training process. A minute ago I changed the settings to be training mode. So I'll do that again, press play. Now, as soon as it begins, we'll start to see the output in the terminal, which shows that training has begun. There we go. So training has begun. So we're now going to go over to Tensorboard, and we can start to see some numbers appearing, these graphs. Now, there are a lot of metrics that we get out of the box with PPO via stable baselines. Two of them, which are very useful, come out of what's called rollout. Rollout is kind of a wrapper for various metrics. Two of those metrics are the average episode reward value. So it's the average reward that the agent is seeing from the game, and the average length of the episode. The latter, this average episode length, is the one that we're particularly interested in. They're both useful. We want the reward to be as high as possible, and we want the length of the episode to be as low as possible. Because if you remember, an episode is defined as when, from the start of the game until the player has collected all of the energy. So this basically means if the player collects the energy more efficiently, then the episode length will be necessarily shorter. So what we're looking for is for the graph of episode length to get as low as possible. And that's what we can see here. It's gone right down to a value of 29.48, and now it's started to creep up a little bit. Reinforcement learning is quite unstable. I will mention that. And as a result, you can find that your training can reach a minima and then start getting quite noisy again. So in a later video, we're going to work out, and you can see a bit of that happening here, if I zoom in, in a later video, we're going to work out how we can capture the very latest and best model of the lot. So I'm not doing very well here at zooming in. There we go. You can see that the length of the episodes has gone down to 29.4 steps at its lowest. But then it kind of goes up again and down again as the machine continues to train. We ideally want to capture this model here, assuming that's the best one, or maybe this one here, 28 in fact. So you can see it's actually going up even more here. So that stability is an issue, and that's why we need to make sure we can capture the best model. And you can see it being reflected conversely, really, where the average episode reward within a rollout has started to go down. A quick reminder of what a rollout is. If you remember, there's a setting in here called rollout length. There it is, 2048. And which goes into the PPO classes setup. The rollout is the number of training iterations before the model is updated and the weights are adjusted to try to learn. So if we go back, that means each of the steps along here, and you can see the steps number moving in the black box beneath, is the end of a rollout. And that's when the model has been updated, and therefore that makes a good place to look at the performance. So that's what a rollout is, and the average episode mean within the rollout is presented here. That's the reward. Sorry, the length is on the left and the reward is on the right. Okay, and we can actually run quite a few of these. So if I just go back to here and I run it again, I'll let that run for a second. While it's running, I'll just talk about what's happening. So firstly, as mentioned, the PPO class that we get through stable baselines 3 will write log files incrementally. I don't know if I mentioned that actually, but it will. It names them based on the type of model, PPO. So it's doing the naming convention. The first one was 1 and the second one is 2, purely because there is a 1 there, so it increments up. The next thing to note is, in this video, we finally let the model complete, and therefore, because we have, if we go down to the training method in PPO, because we have model.save here, after it was completed training, it wrote the model, all of the weights basically, into an energy collection model.zip. The name of that file, of course, comes from model path, which is a constant. This is only created, of course, at the end of the process. And in a later video, we're going to want to try to capture the best model in the process. Anyway, while it's training, let's now go to Tensorboard again. And you'll see that there are now 2 lines. And you'll see they are different. This is because training, particularly reinforcement learning, it starts randomly initialized. And of course, the game is random in its nature. the player positions, the energy positions, they're all different each time, and therefore the training curve is always going to look different. But you're going to hope for a standard setup that you're always going to converge down to a very good result, or up, in the case of the reward, to a good result. And as I said, we want to now stop this at a particular point, which we'll get to later. Right, so that's, I should mention that Tensorboard automatically will refresh itself every 2 minutes, which for big training jobs, particularly things like convolutional neural networks, is plenty fast enough because they could take hours to train. In our case, it generally takes, on my laptop at least, seconds to minutes. So 2 minutes is too slow, but you can use the refresh button in the top right-hand corner to refresh and it will update, or you can just use Control-R to refresh as well, of course. Right, I just want to check I've covered everything off. Yeah, I think that's everything for this video. What we haven't done, and that we're still missing, which caused us a slight bit of a challenge earlier, is we are not using that trained model, energy collection model zip, to play the game. And that caused us an error when we tried to run the game. Down here, if you remember, in the onUpdate method, this is where we decide what to do with the player, so how to set their target position. If it's a human player, we set target position based on the input of the keyboard. If it's a machine, we set the position based on the output from machine learning model. We haven't talked about this line yet. I accidentally had it commented in. But eventually, when we've got the model read in that we've just saved, and we'll read that in during setup if we're not in training mode, that can be used to make a prediction based on the game's state. And therefore, that is how we set the target position of the machine, using the action. Good. Hope that's clear. In the next video, amongst other things, we're going to introduce the artificial intelligence model to our game, and it will be able to play against you for the first time. Okay, and after that, we're going to look at various other metrics and how to visualize the reward landscape that you've had a sneaky peek on before, how to optimize ending the model training so that we can pick the best model, things like that. Because what you're seeing here is a little contrived because I know what's going to work. But when you do this, you may not, and it's important that we have the tools at our disposal to get to the result as quickly as we can. Otherwise, I assure you, frustration is going to come. So I look forward to seeing you in the next video. Thanks for joining me, and I'll see you in video 15.